Hello my dear students, how are you? Namaste to all. So I am talking about the second type of valency, that is covalency. Third one is what you say coordinate valency. So now second one is covalent bond. So such type of bond is formed by mutual sharing of electron in between two non-metals. So always keep in mind. So in electrovalent, what do you see? Transfer of electron from metal to non-metal, and generally found in what you see halides, oxide and sulfide of the metal. But when we talk about the covalent bond, so such type of bond is formed by mutual sharing of electron in between two non-metals. Yes. So for example, so what do you see? Hydrogen. So what do you see? In this case, one electron from hydrogen, one electron from this hydrogen. So mutual sharing of one electron from this hydrogen, one electron from this. So what we have? H. If mutual sharing of one electrons, so that is known as monovalent. That is known as monovalent bond. Yes. If the mutual sharing oxygen, you know valence electron in oxygen is yes. So you know in oxygen how much valence electron? 2, 4, 2, 6. These are the dot is the electron of this oxygen, cross is the electron of that oxygen. So in this case mutual sharing of how much electron? So 2 electrons. Yes. So in this case mutual sharing of one electron. So how many electrons over here? 2. In this case mutual sharing of 2 electron. So what is it? Double bond. That is also known as oxygen molecule. That is known as bivalent bond, or we can say double bond. Yes. Nitrogen has, you know how many valence electron? 1, 2, 3, 4, 5. 5 valence electron. Another nitrogen has how much? So what do you see? So 1, 2, 3, 4, 5. 5 valence electron of this nitrogen. 1, 2, 3, 4, 5 valence electron of this nitrogen. So what do you see? In this case, what is the overlapping? What is the mutual sharing? In this case, mutual sharing of 1 electron. In this case, mutual sharing of 2 electron. In this case, mutual sharing of 3 electron. Why? Look at over here. 6 plus 2, 8. 6 plus 2, 8. So always we have to follow the octet rule. Second one, only we have to involve the valence electron. Yes. So what we have? Nitrogen triple bond. That is the nitrogen molecule. That is known as trivalent bond. So what do you see? H is non-metal, H is non-mutual sharing of 1 electron over here. In this case, mutual sharing of 2 electron. In this case, mutual sharing of 3 electron. Also keep in mind, in this case only 2 electron over here. So, this is duet. It also does not follow octet rule. Why? Because it has only 2 electrons. So, keep in mind, it is also the exception of octet rule. In this case, 4 to 6 to 8, 4 to 6 to 8, it follows the octet rule. It also follows what is 6 to 8, 6 to 8. Yes, 4, 5, 1, 2, 3, 4, 5. That is the valence electron of nitrogen. 1, 2, 3, 4, 5. That is the valence electron of nitrogen. Yes. That is covalent bond. Next one is so also keep in mind. So mutual sharing of electron is maximum is 3, not more than 3. If you get more than 3, you will get Nobel Prize. Yes. So maybe mutual sharing of 1 electron, maybe mutual sharing of 2 electron, maybe mutual sharing of 3, not more than 3. If you do, you will get what is the Nobel Prize, but not so easy. So third one is coordinate bond, or you can say covalent coordinate bond. So in this case, what we see, one atom, central atom, donate one pair of electron, that is donor. Another atom, what you see, accept lone pair of electron, that is known as what you see, acceptor. So in this case, such this bond is formed by by donating lone pair, that is also known as non-bonding electron. It means it does not participate in bond formation. So this bond is formed by donating lone pair of electron by one central atom, that is known as donor, and accepting lone pair of electron by another central atom, that is known as donor. Yes. So this bond is formed by donating lone pair of electron by one central atom, that is known as donor, and accepting lone pair of electron by another central atom, that is known as donor. So look at example of this one. So take very simple example that is very important and generally asked in examination. So we talk about what to see ammonia. Yes. So what to see ammonia, H, that is ammonia. So ammonia has, nitrogen has how many valence electrons? 3 electrons. 1, 2, 3 electron. Yes. So 2 electron is remaining over here. Yes. So 1, 2, 3, 4, 5 valence electron of nitrogen. So in this case, monovalent. Why? Because mutual sharing of 1 electron, mutual sharing of 1 electron, mutual sharing of 1 electron, and that is what you see, that is known as lone pair. That is also known as non-bonding electron. Why? Because they do not participate in bond formation. Next one is boron. Boron, you know, valence electron is 3. What to say? Yes. Chlorine atom. Yes. So what do you see? Boron has how much? 3 valence electrons, monovalent. Yes. Monovalent, that is monovalent. Yes. So what do you see in this case? According to octet rule, there must be 8 electrons in outermost orbit. So what do you see? 2, 4 to 6 only electron. Yes, 6 electron. But in this case, what you see? 2, 4, 6 to 8 electron. No doubt, it is already in octet state. But when you talk about the boron, in this case, how much? 6 valence, 6 electron only. Yes, that is also known as Lewis acid. That is also known as Lewis acid. That is known as Lewis base. Lewis base is always rich in electron. That is deficient. What do you mean by deficient? Poor. Deficient in electron, or you can say poor in electron. Yes, why? 2, 4 to 6 only 6 electron. It does not follow octet rule. But in this case, already 2, 4 to 6, 8 electron. Yes. So in this case, 2 electron is deficient. Yes. So nitrogen donate 1 pair of electron to boron. Why? Because it needs 2 extra electron for gaining what you see, for fulfilling the what you see octet rule. So what do you see? So we can write like this: N single bond, single bond, single bond. That is the coordinate bond. Cl, Cl, Cl. That is known as coordinate bond, and that is always indicated by arrow. This is coordinate bond. Yes. So this is nitrogen in this case is what you see? Donor. Boron in this case is acceptors. Always there is central atom which donate lone pair of electron, that is known as donor, and another atom which accept lone pair of electron, that is acceptor. Yes, first examples. So generally this example is generally asked in examinations. Very, very important. Yes. So that is donor, that is acceptor. Next example is very, very important, like this. What do you say? Ammonia. Yes. So what do you see? H, H, H. So nitrogen has 1, 2, 3, 4, 5 valence electron. Hydrogen has monovalent, you know, monovalent. Next one is what to say? H plus. H plus means deficient in electron, that is deficient in electron, that is donor. So when ammonia donates lone pair, that is the lone pair, so what we have? H, 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 coordinate bond, and we can write H plus. Yeah, we can write simply ammonium radical, that is ammonia radical. Very important. Both are very important. First one, second one. Yes. So in this case, we have to follow, that is the Lewis dot formula. I will talk about the Lewis dot formula. So in this case, that bond is known as coordinate bond. So I think we have clear. So those central atom which donate that one pair of electron, that is known as donor. Those atom which accept lone pair atom, that is what you see, acceptor. So always we have in this case what we see, donor and acceptor. Yes. Another example. Third example. So what to say, sulfur trioxide. Formula is SO3. So when we talk about the Lewis dot formula, so in this case, we have to keep two things in mind. One, we have to only follow only valence electrons are involved. Next one is only to follow, always it follows octet rule. So I will give you. So what is the sulfur? Central atom. So what is sulfur has? How many valence electron? Sulfur has 6 valence electron. Oxygen has, what do you say? Oxygen has 6 valence electron. Yes. So what we see, sulfur has only 6 electron, oxygen has 6 electron. So to follow the octet rule, what we have? What we see over here? So 2 electron, yes, 2 electrons, what do you say? 2, 4, 2, 6. Yes. So what we see, double bond over here. So what we say, double bond, mutual sharing. Yes. Mutual sharing, 2 electron from here, 2 electron from that side. So mutual electron, what mutual sharing of 2 electron over here. But 2 oxygen is remaining over here. So what do we see over here? What do you see over here? So already sulfur has 4 to 6 to 8. This oxygen has 4 to 6 to 8. Now 2 oxygen is remaining over here. So what do you see? Sulfur coordinate. What do you see? Oxygen has how much? 6 valence electron. Another oxygen has also 6 valence electron. So in this case, already sulfur is already in octet state. But when you talk about the oxygen, how much? 2, 4 to 6 only, 6 only. So what do you see? Sulfur donate 1 pair of electron to oxygen. This sulfur donate 1 pair of electron to oxygen. So what we write over here? Yes, coordinate bond, that is coordinate bond, that is double bond, that is double bond, that is coordinate bond, that is also coordinate. Yes, right, we have think. So in this case, sulfur acts as a donor, Oxygen acts as a, in this case sulfur is donor, oxygen is acceptor. This oxygen is, and what you see, mutual sharing of 2 electron over there. So, bivalent, and that is what you see, what is a coordinate bond, coordinate bond, yes, 2 coordinate bond and 1 double bond over here, yes. So, I think you have cleared coordinate bond, 1 atom donate lone pair of electron, that is known donor, and now the what you see accept lone pair of electron, that is known as acceptor, yes. So, that is about the coordinate bond, yes. Now, next one is generally ask you what to see Lewis dot formula. Lewis, name of the chemist, Lewis electron dot formula of compound or ions. Yeah, we can say radicals, or you can say radicals. So, that is also very important. So, for doing Lewis dot electron dot formula, always so many rules over here. So, we keep 2 rules always we have to follow. We have to follow 2 rules over here. First rule is only valence electron are involved in bond formation. Only valence electrons are involved in bond formation. Yes, keep in mind. Second one is to form a bond, we must follow octet rule. Octet rule. Yes, I have already told you. Valence electron means those electrons which are found in outermost orbit of an atom, and that is responsible for bond formation. And octet rule means to form a compound we must follow, octet means must be 8 electrons in outermost orbit. So, always we have to keep 2 rules. Yes, so many rules, but mainly 2 rules we have to keep in mind. Only valence electrons are involved in bond formation. Second one is to form a bond, we must follow octet rule. Yes, so always we have to follow these 2 rules. I am telling you something about the one formula. One simple formula which is used to get number of bonds in a molecule, or you can say ions. Yes. So, rule is what you say, S is equal to N minus B. S is equal to N minus B, where S means number of electrons used for sharing. Second one is what is N? N means total number of electrons required to required for all atoms to complete octet. Yes, B is what is the number valence electrons present in a molecule, or you can say ions. So always we have to keep three terms. S means number of electrons used for sharing. N, total number of electrons required for what you see all atoms to complete octet rule, you know. Number of valence electrons present in a molecule, or you can say ions. So see the example. For example, what is the sulfur dioxide? That is sulfur dioxide. So how many sulfur atom? 1. So S is equal to 1 into what we say for sharing, for getting octet rule, how many electron we need? 8. Plus how many oxygen atom? 2. For what you see completing octet rule, how much we need? 8. So how much? 8 plus 16 means 24 electrons. Yes, S means 1. How many? 1 sulfur atom. For what you see sharing, for octet rule, how much electron we need? 8. 2 electron oxygen. So what we have? 2 into 8. How much? 24 electrons. So what you see? N in this case is yes, it means it was not yes, that is the N. Now the what you see? B means valence electrons. So how many oxygen? Sulfur 1. How many but valence electron of what is sulfur? 6 plus 2 oxygen atom. So what you see? 6. So what you get? 6 plus 12. How much get? 18 electrons. Yes. So when you talk about the S, what you see? N minus B. So what you get? 24 minus 18. So what you get? 24 minus 18, how much get? 6 electrons. Yes, sharing electron. Sharing electron, how much? 6. Now bond, number of bond in this case is 6 by 2. Why? Because for bond formation at least we need 2 electrons. So we have to divide by 2. So how much get? 3 bonds. Covalent bond. But in this case, matter of what you say. So this bond does not say how many covalent bond, how many what you see monomer bond, how many covalent bond. In this case, no any clear idea about. But it needs some practice. So I will give you some key. So with the help of key, we can do the Lewis dot formula of most of the compounds. So what's the 3 bonds? So now sulfur dioxide. So you know sulfur has how many valence electron? I guess 6. Sulfur oxygen has how many oxygen? Oxygen. Yes, 6 electrons. So what do we see? So sulfur has 6, oxygen has 6. What do you see? Mutual sharing of 2 electron. 2 electron over here, 2 electron from oxygen. So mutual sharing of 2 electron over here. So remaining one is what you see, one oxygen. So oxygen has what you see, how many valence electron? 6 valence electron. So what we see over here, 4 to 6, 8. Sulfur is already octet state. Oxygen is 4 to 6 to 8, already in octet state. So what we see, oxygen has only 6 electrons. So sulfur donate one pair of electron to oxygen. So sulfur in this case is donor. Oxygen in this case is what you see, acceptor. Yes. So what we have, sulfur double bond, coordinate bond. So 2 bond and 1 bond. How many? 3 bond. 3 bonds. So it does not says so clearly how many covalent bond, how many coordinate bond. Yes. So it needs some practice. I think you have clear what is the S is equal to N by B. So with the help of this, we can get, we can what to see, we can write the what to see Lewis dot formula of most of the compounds. But I will give you some keys by which we can write the what to see Lewis dot formula very easily. Now, first one is SO3, sulfur trioxide. Is what is this? It's a key. With the help of key, we can what is write the Lewis dot formula easily. So what we have, sulfur double bond, coordinate bond, coordinate bond. Yes. Second one is sulfuric acid. In this case, always central atom is always keep in what we see center. Yes, sulfur in the center. So what we have, OH, then what you see, 2, 4. So what you see, coordinate bond, coordinate bonds. You have clear what is the monovalent, what is the coordinate bond. Yes, that is about the sulfuric acid. Next one is S2SO3, sulfurous acid. How many what's hydrogen? Sulfur, 2 hydrogen over here, OH. How many oxygen over here? So what we see, one is coordinate bond. Here 2 coordinate bond, here 1 coordinate bond. These all are the key. So with the help of key, we can draw a Lewis dot. We can write the Lewis dot formula of any compounds. For one, HO3, nitric acid. What we have? Yarn 1H over here. So what you see, double bond. What do you see? Coordinate bond. So 4 to 6 to 8. Yes. Always you have to follow the what you see. We have to involve only the valence electron, and only to form the bond. Always we have to follow octet rule. These 2 rules are very important while you do Lewis dot formula of any compound. Next one is HNO2, that is nitrous acid. What do we see? Yarn OH, double bond. Yes. 6, nitrogen tetraoxide. We can also find with the help of this S equal to N minus B. So it need, in the help of this we can do easily. Yes. So what you see, N N double bond, coordinate bond, double bond, coordinate bond. Next one is four, six, 7 N2O5 nitrogen pentaoxide. So what we have? NO, N double bond, coordinate bond, double bond, coordinate bond. 8 nitrogen tri. How many oxygen? Tri. Trioxide. So what we see? NO double bond, double bond. 4, 9, that is nitrous oxide, that is also known as laughing gas. So what we have? NON, coordinate bond, coordinate bond. Yes. So in this case, look at over here. So nitrogen, if single bonds, what we have? One electron from nitrogen, one electron from oxygen. Yes. Like this, monovalent. What do you see? One from oxygen, one from nitrogen. So what do you see? Nitrogen. So nitrogen, remaining one is 4. Yes. Oxygen has how much remaining one? 4. Yes. So what we see? Oxygen is already octet. 2, 4, 2, 6, 2, 8. But when you talk about the nitrogen, 2, 4, 2, 4, 2, 6. So this oxygen is already in octet state. But when you talk about the nitrogen, when you talk about this nitrogen, what do you see? 2, 4, 2, 6 only. 2, 4, 2, 6 only. So it does not follow the octet rule. So what happens over here? So 2 electron goes over here. 2 electrons goes over here. So what do you see? Coordinate bond, monovalent, monovalent. Yes. Likewise, ten nitric oxide. So what do you see? Nitrogen. Nitrogen has oxygen. Yes. Yes. So what is oxygen? 2, 4, 2, 6. So already in octet state when you talk about the oxygen. But when you talk about the nitrogen, what do you see? 4, 2, 6 and 1, 7. So it has no 8 electron over here. So one electron from oxygen shift towards the nitrogen. So that is known as singlet bond. Why? Because only one electron is donated by oxygen to nitrogen. So how can we write? Nitrogen double bond, and what do you see? Yes. That is known as singlet bond, given by Sajan. Name of chemist, that is single. Why one arrow? Because it donates only one electron over here. Yeah? Donor. Only one electron. Likewise, when you talk about the ions, sulfate. So what do you see? Sulfur sulfur has what you see 6 electron, but 2 negative over charge, so 2 electron extra over here. So what you see? Yes. So how many oxygen? Oxygen, 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 2 electron given by any metal, or we can say hydrogen atom. Yes, so what we can write? So 2 electron extra over here. So what we can write? Negative charge over here. Yes. Twelve. Sodium thiosulfate. So what do you see? Na2H2O3. So better to ionize in this case. After ionization, what you get? Reverse sign. So what you get? H2O3, 2 negative charge over here. Yes. So Na we had not draw over here. So we can write Na plus oxygen negative, Na positive, oxygen, sulfur. That is the what's Lewis dot formula. Lewis. So we can arrange in what is the Lewis dot formula. 12, 13, suppose like this. Ammonium nitrate. So ionize, better to ionize. So what we have? Plus nitrate. What we have? Ammonize. What you see? What we get? Yes. You know the